Okay, so this next section is all about inverse trig functions. And we've talked about inverse trig functions before, though it's been a while. And if you remember, an inverse trig functions takes a ratio of side lengths to calculate an angle measurement. In other words, instead of evaluating sine or evaluating cosine of the angle and getting a ratio back out, we're doing it the reverse. So it's how we undo a trig function. It's the opposite of that. So if we're trying to find x, we want to take the arcsine or the sine inverse. This is what we were more familiar with before, was writing it this way as the sine inverse of x, which you can actually see then on your calculator. So on mine, my sine inverse, cosine inverse, and tangent inverse. And we used this before to get at our angle. And remember, sine inverse is not the same thing as 1 over sine, which means this is not the same thing, not equal to cosecant. Okay, these are definitely not the same thing. Arccosine is the cos inverse, cosine inverse, and arctangent is the tan inverse. And again, it's just how we undo our functions to get at our angles. Now the ranges of these inverse functions are actually restricted. And the way they're restricted is based on quadrants. So if we're looking at arcsine, arccosecant, and arctangent, we want to figure out these quadrants that give us both positive and negative ratios. So arcsine and arctangent and arccosecant are restricted to quadrants 1 and 4. So it's restricted to the right half of our plane, where I can have our sine be negative in quadrant 4 and our sine be positive in quadrant 4. And on the other hand, our cosine, our secant, and our cotangent are restricted to quadrants 1 and quadrant 2. It's the upper half of our plane, where cosine is positive in this value or in this quadrant and negative in this quadrant. Same thing for secant and same thing for cotangent, positive and negative. And these things you do have to know. You do have to memorize where my restrictions are for my ranges. Okay, so back when we did this the first time, we were finding the angle measurements in radians of theta, given that the arcsine is negative 1/2. So the way we thought about this before was, what angle gives a value or gives a ratio of negative 1/2? That's our thought process behind this. What angle actually gives that value? So on our quadrant or on our unit circle, again, we're restricted, arcsine, we're restricted in either positive or negative, quadrant 1 or quadrant 2, and since we're given a negative ratio, we're in quadrant 4. And we're looking for what value would sine be 1/2. That's what we're thinking. Well, our theta here would be a 30-degree angle, and it's a 30-degree angle on the going in the negative direction. So this is really 130 degrees, if we take 30 degrees off my entire 360, or negative 330, or 30 degrees. Now we want this in radians, so this is either 11 pi over 6 or negative pi over 6. So back to thinking of our measurements between these. Now you can convert that. You can take 330 and you can multiply by pi over 180 to find that. If that still works for you, then great. But this again is something that you should probably be, refamiliarize yourself with, that conversion from degrees to radians. So when we have the given function as an inverse trig function, so if we have something that we know on a unit circle, we must restrict our answer to one of our quadrants, and we want our answer in radians. So for example 2, again, this is restricted between tangents restricted between 1 and 4, tangents negative, our arctangent ratio is negative, which means we're restricted to quadrant 4. And the tangent of 1, or to get that ratio, we must have a pi over 4 or a 45-degree angle. So this is our theta, which means we're at 315 degrees, 360 minus 45, or negative 45 degrees, which means that theta is either 7 pi over 4, or you can write it as negative pi over 4. You don't need both those answers, but those are both acceptable. Alright, continuing on, same idea. Arc sine, again, we're in quadrant 4, since we're restricted to 1 and 4, and our sine ratio is negative. To get negative root 3 over 2, we need a 60-degree reference angle. And this happens at either, looking at our triangle, 300 degrees, or we could write it as negative 60 degrees, which is either 5 pi over 6, 5 pi over 3, or negative pi over 3. Alright, for example 4, we're looking at arc secant. So instead of 1 and 4, which we were just used to for arc tangent and arc sine, we're restricted to 1 and 2, and this is negative, which means we're restricted to quadrant 2. Secant's 1 over cosine, so this came from, we could write it this way, as arc cosine of negative 1 over root 2 if we take the reciprocal of our inside ratio, which really means we're looking for where arc cosine is negative root 2 over 2 if we rationalize the denominator there. Well, that we know happens at a 45-degree angle, or 45-degree reference triangle. So this is at 135 degrees, 180 minus 45, which gives us 3 pi over 4 in radians. For the next one, example 5, we're looking for what kind of ratio would give cosine of 0. So where, we're asking ourselves, what theta, what angle is cosine 0? Well, that happens at pi over 2 and 3 pi over 2. But since we're just looking at quadrants 1 and 2, because our range is restricted, our answer is just pi over 2 for that. Again, note that it's not 3 pi over 2 because that is not in the range of arc cosine. So when we know the trig ratios, we want to give exact values, we want to give the exact angle. Otherwise, when we're looking at, for example, this next part, example 6, that's definitely not one of the things that's on our unit circle. So we can just plug that into our calculator. So we're looking for cosine inverse of negative 0.13348. And again, this is going to be in degrees, so we're using like approximate degrees. So that means that our calculator should be in degree mode. So make sure that your calculator is in degree mode. And we're looking for cosine inverse of, we just plug this into our calculator, 0.13348. And it gives us approximately 97.67 degrees. Okay, for the next one, arc cosecant, remember just how we treated this one above, we have to take the reciprocal of the inside to change that because we don't have secant on our calculator. We just have we don't have cosecant or secant on our calculator. We just have sine, cosine, and tangent. So this comes from arc sine, or we're treating this as arc sine of 1 over negative 1.287. So that's how we're actually going to plug that into our calculator. Sine inverse of 1 divided by negative 1.287. And we get approximately negative 50.99 degrees. So again, the whole idea here for our inverse is finding an angle. We want to figure out what kind of angle gave that ratio, the ratio that's on the inside of our function. And we do that using our reference triangles. We do that drawing our figures on our paper about what quadrant we're in, and using the angles that are on our unit circle to figure out that answer. Okay. On the back side, it's a little bit different. We're dealing with compound statements. So just as a reminder, remember an inverse trig function represents an angle. So for all of these things that we're dealing with two different kinds of functions, we're taking the sign of an inverse. So the first thing that I want you guys to do for all of these is to draw a reference triangle. Draw a reference triangle. So for this one, example 1, this step on the inside, the arctangent, again, represents an angle. So we're trying to find really the sign of some angle. So the way we tackle this is we draw a reference triangle. Tangent's restricted to 1 and 4, and it's positive, so we're in quadrant 1. And we have the ratio of 3/2, which means that our angle, theta, our tangent value is 3 opposite over adjacent. Okay, and then we find this hypotenuse. We need that because we're going to have to find the sine of theta. So 3 squared plus 2 squared equals 9 plus 4, which is 13, which means that our hypotenuse is root 13. Now all we have to do is find the trig function based on the triangle. So again, this is an angle. We've used it to represent that angle. We're not actually like evaluating it. We're not plugging it into our calculator and then taking the sine. Then we can use our triangle here to actually evaluate the sine of theta. Well, the sine of theta is opposite over hypotenuse. And then we rationalize, multiply by root 13 over root 13, so we get 3 root 13 over 13 as our answer. Okay, same idea. Cosine inverse, again, that's an angle. So first thing we do, draw a reference triangle. Cosine's restricted to 1 and 2. This is negative, so we're going to be in quadrant 2. And we're using this ratio here to label our triangle. So negative 5 over 13. And we can complete this using our special triangles. That this is going to be 12. And this is theta. So the tangent of theta is opposite over adjacent. So 12 over negative 5. And that's our answer. Okay, example 10, same idea. We're finding the arc cosine of 1/2. So cosine is restricted to 1 and 2. This is positive, so we're in quadrant 1. Adjacent over hypotenuse. And we can use that to complete this angle. So 2 squared minus 1 squared. So 4 minus 1 is 3, meaning our adjacent side is root 3. Okay, this is our theta. So then we're going to evaluate cosine of theta, meaning we look at theta and we evaluate where our cosine is. So that's going to be adjacent over hypotenuse. Wait a second. So this cosine, we started with cosine of arc cosine, and then we ended up with 1/2. We ended up with the same ratio. So if you have cosine of cosine inverse of whatever is on the inside, these things cancel out. Remember, our inverse is how we undo a trig function, and vice versa. If we're trying to undo an inverse, we take a trig function of that. Now this only works when they're the same. Don't try to cancel out cosine and secant. That does not work. But cosine and cosine inverse, those do work. Or cosine and arc cosine work. Same thing with like tangent and arctangent. That would also cancel out. Okay, so here's where it gets tricky. when you're dealing with stuff that is more complicated, you have two angles that you're dealing with. Because I have tangent inverse, which is an angle, right? I'm going to deal with, say that's angle A, and sine inverse, which is another angle, some angle B. So we're treating this as cosine of A plus B, which is a sum and difference. We just took a test on that. So this is really cosine of A, cosine of B, minus sine of A, sine of B. And we have to evaluate using these angles. So again, we're just going to draw some reference triangles. So we're going to draw a reference triangle that's representing A. We'll draw a reference triangle that's representing B. It tells us that the tangent inverse is root 3. So tangent's restricted to 1 and 4. It's positive, which means we're in 4. And this is our ratio of root 3 over 1. So opposite root 3 over adjacent 1. And then we can find our other side lengths. So 1 squared plus root 3 squared is 1 plus 3, which is 4. Take the square root, we get our hypotenuse is 2. Okay, and then we're going to do the same thing for B. In this case, again, we're in quadrant 1 because our sign's positive. Opposite over hypotenuse. If we try to solve that, we'll have 3 squared, our hypotenuse, minus 1 squared. 9 minus 1 is 8. Root 8, if we simplify that, is 2 root 2. Okay, now that we have both of our reference triangles drawn, we can evaluate our cosine of A and our cosine of B and sine A and sine B based on the triangles, based on the reference triangles that we've drawn. So the cosine of A, here I am in A, this is my angle value. Cosine is root 3 over 2, opposite, 1 over 2, adjacent over hypotenuse. Cosine of B is adjacent over hypotenuse, 2 root 2 over 3, minus our sine A, which is adjacent over hypotenuse, and our sine B, which is adjacent over hypotenuse. And then we simplify just like last chapter. So 1 times root 2 over 2. We're going to end up with 6 minus root 3. Root 3 times 1 is root 3 over 6. And we combine that into one single denominator of 2 root 2 minus root 3. And that's our final answer. For this next one, we have a double angle. So this is really the tangent of labeling arcsine as theta. It's really the tangent of 2 times some theta. And we know that the tangent of 2 times some theta is 2 tangent theta, 1 minus tangent squared of theta. So we have to use our trig function, our double angle identity, to evaluate that. Well, we need tangent of theta, right? So we need to evaluate this. We need to draw a reference triangle. And in this case, we're going to draw it in quadrant 4 since we're dealing with sine, and our sine ratio is negative in this case. Our opposite is negative 3 over our hypotenuse of 5, and this is a 3 over 5 triangle. So that means that we can find our tangent of theta is negative 3 over 4. Okay, so we'll plug that in everywhere we see tangent of theta. So 2 times negative 3 over 4 over 1 minus negative 3 over 4 squared. Okay, this will become 2 over 1, so 2 times negative 3 is negative 6 over 4. On the bottom here, we'll square both our top and our denominator, so 1 minus negative 3 squared is 9 over 4 squared is 16. And we need a common denominator down here in the denominator, so I'll treat this one as 16 over 16 minus 9 over 16. So in the denominator here, I'll have 7 over 16. And you could leave this as negative 6 over 4 and then flip and multiply by the reciprocal, so we'd have negative 6 over 4 times 16 over 7. And I can reduce my 4 and my 16, divide them both by 4, just to save me some reducing later on. And I get negative 6 times 4 is negative 24 over 7. And that's my final answer for this problem. The tangent of 2 arc sine of negative 3 over 5 is negative 24 over 7. Okay, so we'll do the same thing here. This is our theta. Again, drawing a reference triangle. In quadrant 4, since our sign is negative, opposite over hypotenuse, and if you solve that, you should get the square root of 15. Okay, we're looking for cosine of 2 theta, which means I'm going to use one of my cosine of 2 theta identities. So I'm just going to use the first one that we had listed on that paper. So 2 cosine squared of theta. And I'm going to plug in the squared value of my cosine and then square it. So my cosine in this is adjacent over hypotenuse, so root 15 over 4. And I'm going to square that. So root 15 squared is 15. 4 squared is 16 minus 1. This is 2 over 1, multiply the tops, 30 over 16, minus, I'm going to make this a common denominator right now, minus 16 over 16. And I get 14 over 16, or I can reduce that, divide the top and bottom both by 2 and get 7 over 8. Last one here, again, we find our sine inverse. That's going to be a theta. So we're dealing with secant of 2 theta, which we don't have our secant value. That's not one of our trig identities for our double angles. But secant is 1 over cosine of 2 theta, which we just found cosine of 2 theta is 7 over 8. So we can plug that in here, 1 over 7 over 8. Which is really, if we multiply by the reciprocal, 8 over 7. So again, this just holds the same rules. If you're looking for secant versus cosine of this same identity, it's really the reciprocals of each other. It's nothing more complicated than that. You don't have to do anything special. It still holds true. Those same ideas are still valid. You can still just take the reciprocal. Before I finish up, I just want to show you how you can check your work on your calculator through this. Though you should still go through these reference triangles and you should still have the same process. But if I were to check my work for, say, this one up here, our tangent of cosine inverse, I could literally just plug all this into my calculator. The tangent of cosine inverse of negative 5 divided by 13. I press enter, I get 2.4, which is 12 over negative 5. So I'm getting the same answer here just by plugging in what I have. So this is definitely a good way to check your work as you're going through your problems, just to make sure that these things are equivalent. So again, I could do the same thing, say, for number 11, example 11, the cosine of tangent inverse of root 3. The only thing here is that you have to watch your parentheses, so I'm doing a double parenthesis around that root, but not a triple one because I don't want to close out my cosine yet, plus sine inverse of 1 divided by 3. And I get 0.1827. So I can check my answer. I got this as my answer, 2 root 2 minus root 3. Put parentheses around that whole thing, divided by 6, and I'll get 0.1827. So I get the same thing if you check your answer, your final answer, with your starting answers, putting that into the calculator. So same thing down here, even if I was dealing with something like this, cosine of 2 inverse sine of negative 1 over 4. It's 0.875, which is 7/8. So you can definitely use your calculator for that. Okay, your homework for this weekend is on the bottom of this paper. Page 250, numbers 5 through 41 odd and 57 through 79 odd. I know it seems like a lot, but this stuff is something that we kind of have to get quicker with, and we're a little bit pressed for time since our next test is the Tuesday before Thanksgiving. So we're trying to cram this section and this unit into this last week and a couple days here. This video is going to be posted on Google Classroom as well, so you can rewatch that if you didn't get all the parts to that. And you can pause it. There are tons of videos out there. I can post some other resources as well, just to get a little bit more background as you guys are doing these problems. Again, resist the urge to use a calculator unless it's an approximate answer. So try your best to draw your reference triangles and only use your calculator to check your answer at the end.